Therefore the power series solution of given differential equation one is y is equal to summation and runs from 0 to infinity a n x raised to n, that is a naught plus a1 x plus a2 x square plus a3 x cube plus a4 x raised to 4 plus a5 x raised to 5 and so on, that is y is equal to a naught plus a1 x plus value of a2 is a naught by 2, 1/2 a naught value of a2 plus a3 is 1/6 minus 1/6 a1 x cube, there is a naught x square, then 1/6 minus 1/6 a1 x cube value of a3 plus value of a4 minus 1/8 a naught x raised to 4 minus value of a5 minus 1/24 plus sign minus 1/24 plus 1/24 a1 x raised to 5 x raised to 4 here is a6 is there, a6 is what, this a5, then plus the value of a6 7/240 a naught x raised to 6 plus value of 112 value of what, a7 112 a1 x raised to 7 plus so on, and therefore final answer is y is equal to the constant terms first 1/6 x cube minus 1/24 x raised to 5 plus 1/112 x raised to 7 and plus or next term minus plus a naught, the coefficient of a naught 1 plus 1/2 x square, this term 1/2 x square plus not plus minus 1 by this minus 1/8 x raised to 4 plus 7/240 x raised to 6 plus so on, and the plus a1, the coefficient of a1 is x, this x minus 1/6 x cube plus 1/24 x raised to 5 minus 112 x raised to 7 plus so on. So this is the final answer. This is the power series solution of the given differential equation. This is the power series solution of the given differential equation. Next, is this. Find the power series solution of Legendre's differential equation 1 minus x square y double dash minus 2x y dash plus p plus 1y is equal to 0. So substitute this y double dash. Summation n runs from 2 to infinity n minus 1 an x raised to n minus 2 minus this 2x summation n runs from 1 to infinity n x raised to n minus 2, this is the value of y dash, plus this p plus 1 summation n runs from 0 to infinity an x raised to n. The value of y. Okay, then multiply by this factor to this bracket. So we have this term, 1 into this is this term, then x square minus x square into this term minus 2x, shift this minus 2x in the summation. So we have here is 2 and x raised to n minus 1 into x is x raised to n plus summation n runs from 0 to infinity p plus 1 an x raised to n, this term, this p and p plus 1 in the summation. Then replace this summation n runs from 2 to infinity replaced by summation n runs from 0 to infinity, and the factor is what? Replace n by n plus 2. Okay, summation replace this n by n plus 2, we have this, and then this x square and x raised to n minus 2 becomes x raised to n, then this term as it is, this term as it is. Okay, then next step is what? This term as it is. Now observe this term, n runs from 2 to infinity is replaced by n runs from 0 to infinity, but here this n is not replaced by n plus 2. Why? Because if we substitute n is equal to 0, then in this formula, then we have answer 0. So 0 is added, and if we substitute n is equal to 1 in this formula, then what we have? This is 1, but n 1 minus 1 is 0, and then again we have n is equal to 0 answer. So if n is equal to 0 and n is equal to 1 in this formula, we have both terms are equal to 0. So by adding 0, there is no change in the LHS side. So just added 0 2 times. N is replaced from 2 to infinity by n runs from 0 to infinity. Just added 0 2 times. That's why don't write this n, replace n by n plus 1 or n plus 2. Then next step, this n runs from 1 to infinity is replaced by n runs from 0 to infinity, because if we substitute n is equal to 0 in this formula, 2n n plus n into x raised to n, then we have answer 0. If n is 0, then this we have is equal to 0. And therefore just 0 is added, and this term as it is. So observe this step, all these powers of x are what? Raised to n, x raised to n, here is we have x raised to n, here we have x raised to n, here we have raised to n. If we replace this n by n plus 2, then this x raised to n becomes x raised to n plus 2, and it is then it becomes odd term. That's why we want all these powers of x is equal to n. That's why this is the adjustment. Don't replace here is replace n by n plus 1. Here is the, here if we write n sum from 2 to infinity, we have to reduce this to n is equal to 0 to infinity, replace n by n plus 2. But it's supporting to your calculation, because n minus 2 becomes x raised to n. So all the terms are then converted to x raised to n, and all the terms are converted to summation n runs from 0 to infinity. Here is summation n runs from 0 to infinity. Here is summation n runs from 0 to infinity. Here is summation n runs from 0 to infinity. In all four terms, the summation is what? Runs from 0 to infinity. And observe all these four terms, the power of x is n. So that's why this is the adjustment. Here this n runs from 2 to infinity, reduced to n runs from 0 to infinity, but by not by using replacing n by n plus 2. Here is n, replace n by n plus 2. But here, because if you replace n by n plus 2, then this x raised to n becomes x raised to n plus 2. But we want all the powers of x is equal to n, and summation n runs from 0 to infinity. That's why we have this. Then take this summation n runs from 0 to infinity as common, x raised to n as common, this bracket. Then this bracket is 0 for all n runs from 0, 1, 2, 3. This is the Legender's equations, and this is a homogeneous differential equation but without constant coefficients. This y double dash, the coefficient of y double dash is 1 minus x square. In the power series solution, it is not essential to reduce this coefficient of y double dash equal to 1. Don't reduce this equation as a power as a coefficient of y double dash is equal to 1. It is not necessary. If you find singular points, then it is essential. So we have this, and then we have this is equal to 0 for all n is equal to 0, 1, 2, 3 up to infinity. Then find the value of an plus 2 from this equation. This is the value of an plus 2. This n square plus n minus p plus 1. This is the calculation. What is an plus 2? N plus 2 is this, n square plus n from this step. N runs from. Then substitute n is equal to 0. What do we have? N is equal to 0. A2 is equal to. Substitute in this formula, n is equal to 0. We have this. Then substitute n is equal to 1 in this formula. Then we have A3 is equal to this by substituting n is equal to 1. So the calculation of this 2 minus p into p plus 1 is this, minus p square plus p minus 2 divided by 3 factorial 6 means A1. We have value of A2 in terms of A0, value of A3 in terms of A1. The factorization of this p square plus p minus 2 is this. Then substitute n is equal to 2. We have A4 is equal to this 6 minus this 4. 2 square is 4 plus 2, 6 minus p plus 1 divided by 4 into 3, A2. Substituting n is equal to 2. So we have this calculation divided by 12. And the value of A2 is what? This is A2, p minus p plus 1 by 2 factorial means 2, A0. Then calculation is this. The factorization of this is p into this p plus 2. And then we have this value 24 divided by 24 means 4 factorial, A0. This is the value of A4. Then value of A5, for that could substitute n is equal to 3. We have A5 is equal to, this is the answer, A3. Substitute A3, and this calculation of this is what? 12 minus p square minus p, take this minus sign common, p square plus p plus 12 becomes minus 12. This factorization is p plus 4, p minus 3, the factorization of this, and this is the value of A3. So we have, this is the value of A5. Similarly, substitute n is equal to 4 in that equation. So we have A6 in this form, A4, substitute A4, and so we have A6 is this. Okay, this is the A6, that p minus p plus 1, p plus 3, p plus 5, p minus 2, p minus 4, 6 factorial A0. This is A6. Okay, so A8 is what? In similar fashion we can write A8. What is A6 and A4? If we observe A4 and A6, then what is A4? Is p plus 1, p plus 3, p minus 2. So here the terms are plus minus A6 and A8. So what is A6 is minus, so A8 is plus. P plus 1, p plus 2, p plus 5, p plus 1, p plus 3, p plus 5. Here p plus 1, p plus 3, p plus 5, p plus 7, p minus 2, p minus 4, and then p minus 6. Similarly, A7 is what? If we observe A5 and A7, Then what is A5? P plus 2, P plus 4. Here is P plus 2. This term is plus, this term is minus. P plus 2, P plus 4, P plus 6. And P minus 1, P minus 3. Here is P minus 1, P minus 3, P minus 5 divided by 5 factorial. Here is 7 factorial A1. So these terms. So A2, A4, A6 and A8. Observe A1, A3, A5, A7. These are the similar terms. So the power series solution is what? This is the power series solution. Y is equal to A0 plus A1x plus A2x square plus A3x raised to 4. Substitute the value of A0 as it is, A1x as it is, minus this value of A2 is this, minus P plus 1 by 2 factorial A0 x square. Similarly, substitute the value of A3, A4, A5, A6, A7, A8. Substitute all the values. And then take this A0 as common. We have this is the bracket. And take the A1 as common. We have this bracket. Okay, in bracket. What is the terms? Here plus term 1 plus, then minus, plus, minus, plus, minus the terms. And here is also plus, minus, this is minus term. A7 is minus term. Here write minus sign, don't write plus sign. A7 is minus term. So plus, minus, terms, then plus term. And observe this is P plus 1, P plus 2, then P plus 3. Here is P plus 3, here is P plus 5 extra term, P plus 7. Okay, and here is here from P minus 2, here P minus 4, then P minus 2, P minus 4, P minus 6. Next term is what? P minus 2, P minus 4, P minus 6, P minus 8. Next term, to find x raised to 10. Similarly, here are the terms P plus 2, P minus 1, P plus 2, P plus 4, P minus 1, P minus 3. So P plus 2, P plus 4 is P plus 6, P minus 1, P minus 3. Here is P minus 1, P minus 3, P minus 5 divided by 3 factorial, 5 factorial, 7 factorial, x raised to 7. So this is the final answer of Legendre's polynomial.